All right, 1 mole of O2 goes on the bottom then. The other side of the equality statement goes on the top.
Like you doing, you basically dividing what you play back down. Hey, you too, sis. Thank you. Now, but like I'm saying, you basically take each number on each side and divide them into two. That's what I'm saying.
I guess you could say that. Sure, yeah. Oh, in the sense you put them in a fraction, divide them. Yes, that's a division problem. Correct. Okay. Now, the actual math here is this is multiplied by that. Let everybody else try it.
Thank you. That's what I heard too. I said that's what I heard too.
All right. Listen. If I thought there was any chance, reasonable chance that that's actually what they said, they'd be written up, okay? In fact, it'd be more than written up, but that, you know.
Oh, what? Oh, my God.
Appropriate talk for class.
Kanye.
Call me Kanye. I'm trying to learn.
Thank you. All right, how many significant digits do I need? Where do I start underlining? With that first 4 there. Wait a minute, I need to cancel all my units. Cancel the species. I didn't even do that up here. Okay. So 1.33. This is grams of O2 here. It's going to be grams of O2 here. Yeah.
How do you know how many How do you know where the underlining is?
Okay. Question I got to ask was, how do you know how many digits to round off 2? Is that correct?
Yeah, like how do you...
All right. You always look in a multiplication division problem. That's what we have. This is division here and here, and this is multiplication between those two. You look for the measured and or calculated numbers in the problem. This is a calculated number. This is a calculated number. Choose the one with the least digits and write your answer in that same number of digits. So this number here has 3 significant digits. The leading zeros are not significant. So if this is the one with the least digits, because this one has 6, then I need my final answer in 3 digits. Okay? So this is the final answer to this question.
So we have to go through all that.
That's what you have to go through. You can do it. Yes. Yes. Alec, you had a question? Oh.
Okay, why don't you give us equations for practice makes perfect.
That's the only way you're going to get it. Yes. Yes. Quiet, please. Please write this as I write. Don't wait till I'm done. William? You are saying something.
Don't get smart, Mr.
I don't get smoked.
completely. At 2.25 grams of the sodium hydroxide reduces in hydrogen chloride.
Hydrochloric acid.
It don't matter. It don't matter. I completely react all the.
Why are you reading this out?
Because he didn't understand.
He wanna laugh. He's trying not to laugh.
Epic fail.
I like this class.
Why?
Did you take your glasses off?
No.
It's still on? Yeah.
I think you need glasses.
No, the light is like shining. Oh, okay. Now I can see it. Now I can see it. Okay. I thought you took them off. I don't know.
Oh my god. He cleaned his glasses. Well, that's good, man.
Okay, Amber, you got this written down? You're playing with your purse and stuff over there. I'm just trying to find out if you already got this done. You're still trying to find a pencil?
Yes, like I had a pencil first of all, and now it's gone.
I got a pencil.
So you have to clean it up.
No, I didn't. It's right there.
You didn't ask me. You didn't ask me. Huh? I got it.
What lady?
Emma, you got a pencil. You talking about
We got 45 letters.
I wasn't eating that.
I know, I understand that. You put away, get away.
I was cleaning out my pencil.
This is a chemistry class. We're way into this class. You've got to stop all that and get to work. Really. You've got a lot to do and you're not getting any of it. Cleaning your purse is something you do at home.
I was talking about a pencil.
I understand. But don't do it again. Put everything away and let's get started. Okay. So with this problem then, the first thing we're going to have to do is find an equation for this. Now you could start with the equation or you could start with a starting amount. Doesn't matter to me which one you do. Okay? But you can't get through this problem without a balanced equation. You can't get through this problem without a balanced equation.
Why not?
Why not?
Because in this, well, I'll tell you what, let me do it. Let me start the problem and work until the point where I need a balanced equation and show you. Okay? So let's start with the starting amount. 2.25 grams of sodium hydroxide. Now you have to know how to write that formula. Okay? That was part of Unit 4, writing the formula. Continue to Unit 5, and now here it is again, Unit 6. Okay? What is the formula for sodium? Na is the formula for sodium. What's the formula for hydroxide? OH. How many of those, how many sodiums and OHs do you put together? It's 1 and 1, but if you don't know how to do that, use your tools. And what tools do you have for that? Huh? Your test references have 2 tools you need for this. Your test references have 2 tools you need for this. Trying to find my copy of those references here. Here we go. Okay. Your sodium is on your periodic table. But to know the charge on the sodium or the oxidation number on the sodium, I've given you a special periodic table that shows all the oxidation numbers. Sodium has a 1+ charge. And you can't find hydroxide on here. It's not an element. Yeah, there you go. It's a polyatomic ion. And for that, use your common ions list. And here's hydroxide. And it's OH negative. Okay? So I need 1 sodium and 1 hydroxide. Is there anybody that still needs me to review how you get 1 and 1? Or does everybody know? Okay. So our starting amount is,
Jasmine is
all right, okay, please give me your full attention. Since the sodium has a 1 plus charge, we're going to put down 1 plus here. Okay? The hydroxide has a 1 negative charge, we're going to put a 1 negative down here. What we need to do is to finish this problem. Well, what coefficients do I put here and here to get that whole thing to equal 0? 1 and 1. Since I need a 1 here and a 1 here, then when I put, that's 1 and 1 of those, when I put them together, if I have any coefficients, they become subscripts. In this case, I don't. I simply put them together to make NaOH. Okay? All right. So we've got to convert this NaOH into moles. You cannot go directly from the mass of sodium hydroxide to the mass of hydrochloric acid. You can't get there from here. You can't get there from here. You got to go through Moleville. Huh? You don't understand Moleville?
No. I don't know.
All right. Starting, listen, starting mass, ending mass. Okay? You cannot get directly from here to there. You have to go through Moleville. Okay?
I vacated there once.
From the starting mass, you've got to get to the starting moles. And to get from starting mass to starting moles, you use molar mass. So we get from here to here, going through molar mass. From starting moles, you want to get to ending moles. And to get from starting moles to ending moles, you go through a molar ratio. Okay? Then from ending moles to mass, anytime you go from mass to moles or back again, you always go through molar mass. So we have a different molar mass, but you're going through the molar mass to get from here to here. What? Well, the question is asking for the mass of hydrochloric acid.
I thought that was the first.
Starting mass is mass of sodium hydroxide. Okay? And so all of this right here, I humorously, I hope, call Moleville.